Type 2. Type 2. Then the denominator has repeated linear factors. When the denominator, when the denominator has repeated linear factors, if the denominator contains repeated linear factors, how to convert it into partial fractions is, observe here, the denominator f of x by g of x is a rational fraction. F of x by g of x is a proper fraction. Then g of x contains the what? G of x contains the repeated linear factors. That means g of x contains repeated linear factors, that is x minus a whole to the power n, x minus a whole to the power n. Then corresponding partial fraction derivative. When the denominator contains a repeated linear factors, how to convert it into partial fraction means, that is f of x by, it is in the form of x minus a whole to the power n. This can be written as a1 x minus c and plus a2 by x minus a whole square plus a3 by, observe here, x minus denominator, x minus up to n times. So this is a repeated linear factors. When the denominator has a repeated linear factor, how to convert it into partial fractions means, f of x by x minus a whole power n is equal to, let us assume that a1 by x minus a up to n degree. So a2 by x minus a whole square, a3 by x minus a whole cube plus and so on up to an by x minus a whole to the power n. Up to an by x minus a whole to the power n. If the denominator has contained repeated linear factors of ax plus b whole to the power n. So f of x by ax plus b whole to the power n is equal to a1 by ax plus b plus a2 by ax plus b whole square, a3 by ax plus b whole cube and so on an by ax plus b whole to the power n. When the denominator has repeated linear factors, or like this also, when the denominator it is in the form of g of x, it is in the form of x minus a whole square into y minus b. If the denominator g of x contains x minus a whole square into y minus b, then f of x by g of x is nothing but x minus a whole square into y minus b. Half take x minus a whole square. This is the one of the linear factor. This is also one of the linear factors. X minus a whole square into x minus b. This can be taken as a by x minus a plus b by x minus a whole square plus. This contains repeated linear factors and also non-repeated linear factors. So in this type we use first and the second method also. So you have a by x minus a whole square, means this is repeated linear factor. So x minus a whole square can be written as a by x minus a plus b by x minus a whole square plus. Here it contains non-repeated linear factor, so that is c by x minus b. First of all, it can be written as like this, and if you do LCM and compare LHS and RHS, we get ABC value right here. We convert it into, so f of x by g of x is converted into partial fraction. Type 2, when the denominator contains repeated linear factors is nothing but x minus a whole to the power n. x minus a whole to the power n, or ax plus b whole to the power n, any linear factor, repeated linear factors. How to convert it into partial fractions means, so f of x by x minus a whole to the power n, f of x by x minus a whole to the power. Observe here, denominator has contain repeated linear factors, This type of proper fraction, how to convert it into partial fractions means, this can be written as, that is a1 by x minus a, a2 by x minus a whole square plus a3 by x minus a whole cube plus and so on, an by x minus a whole to the power. Or if you denominator contains like this, x minus a whole square into x minus b, that means x minus a whole square means it contains the repeated linear factors and non-repeated linear factors. How to convert it into partial fractions means, f of x by x minus a whole square into x minus b means a by x minus a plus b by x minus a whole square. This is a repeated linear factors. So this can be written as a by x minus a plus b by x minus b. Again, non-repeated linear factor is there, so this is c by x minus b. So here we are doing LCM and compare LHS and RHS, we get ABC values. Let us discuss one example here. Yes. Let us discuss one example here. When the denominator has contained repeated linear factors. Let us discuss one example here. Example 1. If you have one proper fraction, that is 2x minus 3 by x minus 3 whole square. X minus 3 whole square. 2x minus 3 by x minus 3. 2x minus 3 by x minus 3 whole square. This is observed here. This is clearly, it is a proper fraction. The degree of f of x is lesser than the degree of g of x, and it contains, denominator it contains repeated linear factors. How to convert into partial fractions is, let this can be written as resolve into partial fractions. Resolve into partial fractions. Let us assume that solution. Let us assume that 2x minus 3 by x minus 3 whole square. 2x minus 3 by x minus 3 whole square is equal to, it contains, denominator contains repeated linear factors. That's why this can be written as a by, we don't know this value, a by, here first of all write x minus 3 plus b by x minus 3. If it has x minus 3 whole cube, a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube. If it has x minus 3 whole to the power 4, this can be written as a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube plus d by x minus 3 whole to the power 4. Observe here, if you do LCM, we get 2x minus 3 by x minus 3 whole square is equal to, clearly the LCM of x minus 3 and x minus 3 whole square. X minus 3 and x minus 3 whole square is clearly, it has x minus 3 whole square. X minus 3 whole square is LCM. X minus 3 and x minus 3 LCM. X minus 3 and x minus 3 whole square. LCM is how much? X minus 3 whole square. 2 and 2 square. LCM is how much? 2 square and 4 only. So x minus 3 and x minus 3 whole square. LCM how much? X minus 3 whole square. So x minus 3 whole square and x minus 3 can cancel a into again x minus 3 plus x minus 3 square get cancelled. X minus 3 into a, we get a into x minus 3 plus x minus 3 whole square, x minus 3 whole square get cancelled. We get b. So x minus 3 whole square and x minus 3 whole square get cancelled. Compare it LHS and RHS, we get 2x minus 3 is equal to a times of x minus 3 plus b. A times of x minus 3 plus b. Putting Putting if x is equals to 3. If x is equals to 3. Clearly, if substitute x is equals to 3, we get 2 into 3 minus 3 is equals to a into 3 minus 3 plus 2 3s are 6. 6 minus 3 is equals to a into 0 plus b. 6 minus 3 is nothing but 3 is equals to 3. So the value of b is how much? 3. We get the value of b is how much? 3. We want the value of a. So observe here. We want value of a. 2x minus 3 is equal to, if you multiply here a into x, ax minus a into 3 is nothing but 3a plus, this is the constant, this is x coefficient here x coefficient is 2. The coefficient of x is here how much? A. Coefficient of x is equal to a. Coefficient of x is equal to here 2. So compare the LHS and RHS, we get x a is equals to 6 minus 3 is equals to how much? A into 0 plus b. So 6 minus 3, 2 3s are 6, 6 minus 3 is equals to b is equals to. So we get a value how much? 2. A value 2. So this can be written as 2x minus 3 by x minus 3 whole square is equals to a value we get 2 by x minus 3 plus b value we get 3 by x minus 3 whole square. X minus 3 whole square. This is the proper fraction. This is each one is called the partial fraction of the given proper fraction. Partial fraction of the given proper fraction. Type 3. When the denominator has non-repeated quadratic factors, how to resolve into partial fractions? If the denominator has non-repeated quadratic factors, then the denominator has type 3. When the denominator has non-repeated quadratic factors. When the denominator has non-repeated quadratic factors. If the denominator has, that is f of x by g of x, denominator has non-repeated quadratic factors, how to resolve into partial fractions means type 3. Observe here, f of x by g of x is a proper fraction. F of x by g of x is a proper fraction. The denominator g of x contains non-repeated quadratic factors. That means that is ax square plus bx plus c, where a not equals to 0. It contains x square plus bx plus c. That means it is irreducible factors. It contains the non-repeated quadratic factors or reducible factors. It contains non-repeated quadratic factors. How to resolve into partial fraction means, then it will be a form of if it has linear factors, we will write numerator constants. If it has quadratic factors in the denominator, numerator compulsory there may be a linear factors. So f of x by that is ax square plus bx plus c. This can be written as it compulsory ax plus by. This is quadratic factors. So numerator compulsory in the form of ax plus b linear factors by ax square plus bx plus c. Ax square plus bx plus c. When the denominator has non-repeated quadratic factors, how to resolve the into partial fractions this proper fraction. So clearly f of x by x square plus bx plus c, f of x by x square plus bx plus c is equal to ax plus b by ax square plus bx plus c. For example, if you take any example like this, right here, if the denominator resolve into partial fractions, that is 2x square plus 1 by x cube minus 1. Resolve into partial fractions. We want clearly this is a proper fraction. The denominator has x cube minus 1. We know that this can be written as 2x square plus 1 by. We know that a cube minus b cube is equal to a minus b into formula. A cube minus b cube is equal to a minus b into a square plus ab plus b square. This is the formula. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Here a value x and b value 1. Substitute here a minus b. That means we get x minus 1 into a cube minus 1 cube is nothing but a cube minus b cube. X cube, x whole cube minus 1 whole cube. This is a value x and b value 1. So a minus b cube is nothing but x minus 1 into a square is nothing but x square plus ab is nothing but x into 1. We get x only, x plus b square is nothing but 1 square. We get 1. Observe here, numerator and denominator. It contains non-repeated quadratic factors. It contains one linear factor and non-repeated quadratic factors. This type of equations, how to resolve into partial fractions is, let us assume that this can be written as 2x square plus 1 by x minus 1 into x square plus x plus 1. X square plus x plus 1. That is equals to, it has a one linear factor, so that's why a by x minus 1 plus, it has a quadratic factors. Nothing but if it has quadratic factor, that can be written as x plus b. So it has a quadratic factor, so this can be written as bx plus c. bx plus c by, this is denominator has x square plus x plus 1. If it has linear factors, we write constants. If it has quadratic factors, we write linear factors. So this proper fraction can be converted into a by x plus 1 plus b by bx plus c by x square plus x plus 1. If you do LCM and compare LHS and RHS, observe here, 2x square plus 1 by, this is x minus 1 into x square plus x plus 1 is equal to, if you do LCM, we get a into x square plus x plus 1 plus bx plus c into we get x minus 1 by denominator, the LCM is x minus 1 into we get x square plus x plus 1. Observe here, the LCM of x minus 1 and x square plus x plus 1 is nothing but x minus 1 into x square plus x plus 1. So clearly, x minus 1 into x square plus x plus 1, x minus 1 into x square plus 1 get cancelled. In the numerator, here, 2x square plus 1 If you multiply, that is ax square plus ax plus a plus ax square plus ax plus a plus bx into x, we get bx square. Bx into minus 1, we get minus bx. C into x, we get cx. C into minus 1, minus. That is 2x square plus 1 is equal to. If you take x square down here, we get a plus b. A plus b. If you take x square here, we get a plus b. If you take plus x as down here, a minus b plus c, a minus b plus c, and the constants are here is nothing but a minus other constants. Compare the coefficient of x square and x and constant terms clearly. Here coefficient of x square is a plus b. Here the coefficient of x square is 2. So clearly a plus b is equal to. Also coefficient of x here, coefficient of x here is 0. So x term is not there. So coefficient of x is equal to 0. But coefficient of x here nothing but a minus b plus c is equal to 0. A minus b plus c is equal to 0. Constant term observe here. Constant term is 1. Here the constant term is nothing but a minus c is equal to 1. A minus c is equal to 1. Or putting x is equal to 1, we get like that also. So a plus b is equal to 2 and a minus b plus c is equal to 0 and a minus c is equal to 1. So we want a, b, c values. This can be written as a minus c is equal to 1, a minus c is equal to 1. So here, what is the c value? C value is equal to, if you transpose, we get a minus 1. C is equal to how much? A minus 1. C value, substitute this one, we get a minus b plus c value how much? A minus 1 is equal to 0. Observe here, a plus a, 2a, this is minus b is equal to, if you transpose 1, we get 1. So 2a minus b is equal to 1, a plus b is equal to 2. This is equation number 1, this is equation number 2. Solve 1 plus 2, we get a plus b is equal to 2, here we get 2a minus b is equal to 1. b get cancelled. 2a plus a is equal to nothing but 3a is equal to a. 3 is nothing but a is equal to 1. A value 3a is equal to 3. A is equal to clearly 3 by 3 we get 1. So a value 1. We want b value. A value substitute in equation number 1. A plus b is equal to how much? 2. A value 1. 1 plus b is equal to 2. b is equal to 2 minus 1. We get b is equal to 1. b is equal to 1. That is b is equal to 1. And also we want c value. C is equal to, we get a value 1. Substitute here 1 minus 1. So c is equal to how much? C is equal to how much? We get a, b, c value. We get a, b, c value. So this can be written as, that is 2x square plus 1 by x cube minus 1 is equal to how much? A value. A value how much? 1 by x minus 1 plus bx plus c. B value how much? 1. So 1 into x, nothing but x by bx plus c. C value 0. So we get b value x by, we get x square plus x plus 1 is the partial fractions of the given problem. This is the type 3. When the denominator has non-repeated quadratic factors. Observe here, when the denominator has non-repeated quadratic factors, that is ax square plus bx plus c. So denominator is in the form of ax square plus bx plus c. How to convert into partial fractions? So this can be written as ax plus b by ax square plus bx plus c. Observe here, if you take one example, this is 2x square plus 1 by x cube minus 1. 2x square plus 1 by x cube minus 1. X cube minus 1. This can be written as a cube minus b cube. 1 cube is nothing but 1 only. So a cube minus b cube. Formula of a cube minus b cube is equals to a minus b into a square plus ab plus b square. So a cube minus b cube equals to a minus b into a square plus ab plus b square. So this can be written as x minus 1 whole cube. So x cube minus 1 whole cube by how much? X minus 1 into x square plus x plus 1. So clearly it has one linear factor and one non-repeated linear factor and one non-repeated quadratic factor. So it has one linear factor and it has non-repeated quadratic factors. So linear factor means this can be written as a by x minus 1. Non-repeated linear factor. So that's why a by x minus 1 plus. It has also quadratic factors. Quadratic factor means numerator composite as a linear factor. So that's why this can be written as ax plus b. How do you calculate? So take bx plus c. Bx plus c. By it has quadratic factor x square plus x plus 1. If you do that, we get this one. So in LHS and RHS compare means numerator, sorry, denominator cancel. Compare numerators, we get a value here 1 and b value 1 and c value 0. Substitute here a, b, c value. We get a value 1 by x minus 1 plus b value 1 into x nothing but x only, c value 0, x plus 0 is nothing but x only, x by x square plus x plus 1 is the answer. This is the third type when the denominator has non-repeated quadratic factors. Type 4, when the denominator contains repeated irreducible quadratic factors. Type 4. When the denominator has repeated irreducible quadratic factors. When the denominator has repeated irreducible quadratic factors. Observe here, fourth type, when the denominator contains repeated irreducible quadratic factors. Irreducible means can't be expressed as a product of two or more polynomials. That is irreducible. So denominator contains repeated irreducible quadratic factors. How to resolve into partial fractions means, that means f of x by g of x is a proper fraction. F of x by g of x is a proper fraction. The g of x contains is nothing but repeated irreducible quadratic factors. That means contains repeated irreducible quadratic factors. F of x by g of x is a proper fraction. F of x by g of x is a proper fraction. Then g of x contains repeated irreducible quadratic factors. That means g of x is equals to contains ax square plus bx plus c whole square into ax square plus bx plus c whole square into some x minus d or abc x minus d. If the denominator contains irreducible, repeated and irreducible quadratic factors, and also contains one linear factor. So, how can we express this in the form of partial fractions? Means So f of x by g of x is nothing but f of x by, here denominator is x square plus bx plus c whole square into x minus d is equals to, clearly it contains quadratic factors. Quadratic factors means compulsory denominator has the linear factors, that is ax plus by. First write repeated, so ax square plus bx plus c plus, it has repeated quadratic irreducible quadratic factor. So that's why take another linear factor, nothing but cx plus d, cx plus dy. This can be written as ax square plus bx plus c whole square plus, also it contains one linear factors. So it contains one linear factor also. So e by, take x minus d. Or if you x minus d is not there means write ax plus b by x square plus bx plus c plus cx plus d by x square plus bx plus c whole square. If it is there means e by x minus d, write one linear factor is nothing but e by x square. No problem. It contains ax square plus bx plus c whole to the power n. Denominator contains repeated irreducible quadratic factors. That means ax square plus bx plus c whole to the power n. How can be written as? Resolving to linear partial fractions means, that is a1x plus a2y, ax square plus bx plus c plus a2x plus a3x plus a4y, ax square plus bx plus c whole square and so on, anx plus bn by ax square plus bx plus c whole power n. Or take, this is easy, that is if the g of x contains a repeated irreducible quadratic factors. That means it contains g of x equals ax plus bx plus c whole square. Also contain x minus d is one of the non-repeated linear factor means this can be written as f of x by ax square plus bx plus c whole square into x minus d is equals to, this is clearly quadratic factor. So this can be written as linear factor ax plus b by x square plus bx plus c plus, it contains again two repeated, so cx plus d by x square plus bx plus c whole square plus e by x minus d is the, when the denominator contains the repeated irreducible quadratic factors that can be resolved into like this. Yes, let us discuss one example, that is example 1. Take any example, that is x to the power 4 plus 24x square, x to the power 4 plus 24x square plus 28. Take any example, no problem. By denominator contains the irreducible repeated quadratic factors. That means x square plus 1 is the quadratic factors and it is repeated, let us do that 3 times. When the denominator has repeated irreducible x square plus 1 can't be written as more than 2 factors. So x square plus 1 is a irreducible quadratic factors, can't be written as product of 2 factors. So that's why x square plus 1 is a irreducible quadratic factors and it has repeated. How to solve this means resolve into partial fractions. Resolve into partial fractions means solution. Let x to the power 4 plus 24x square plus 28y x square plus 1 whole cube is equal to, it has 3 power 3, that means quadratic factor repeated 3 times. So that's why take first one linear factor ax plus b by this is x square plus 1 plus next linear factor take cx plus d by that is x square plus 1 whole square plus, it has repeated also the third time. So take a, b, c, d, e Ex plus F1, Ex plus F1, x square plus 1 whole cube. Clearly it contains only quadratic factors. Clearly it contains only irreducible quadratic factors. That means x square plus 1 whole to the power 3. So this can be written as like this. If you do LCM here, we get x power 4 plus 24x square plus 28. This is clearly 28 by x square plus 1 whole cube is equals to. Clearly 2 square 2 cube. 2 square 2 cube LCM how much? 2 cube only. So x square plus 1 whole square x square plus 1 whole cube. LCM is nothing but x square plus 1 whole cube only. X square plus 1 time get cancelled, we get here LCM ax plus b into x square plus 1 whole square. It has 3 times. If you get cancel 1 time, again we get 2 times. So here x square plus 1 whole square, x square plus 1 whole square get cancelled. Again we get cx plus d into, that is x square plus 1. And plus ex plus f into x square plus 1 whole cube, x square plus 1 whole cube get cancelled. We get 1 over. So clearly, denominator x square plus 1 whole cube, x square plus 1 whole cube get cancelled. Numerator, compare with numerators x square, x power 4 plus 24x square plus 28 is equal to. Observe here, ax plus b into. This can be written as x square plus 1 is nothing but a plus b whole square. A plus b whole square means we get here a square plus, that means x square whole square, we get x to the power 4. A square plus b square means 1 plus 2ab means 2x square. So plus cx into x square, we get cx cube, cx into 1 plus cx plus d into x square, dx square plus d into 1, we get d plus ex plus f, ex plus, multiply here the x plus d, we get x power 4 plus 24x square plus 28 is equal to ax into x to the power 4. We get ax to the power 5 plus ax into 1, we get ax only plus ax into 2x square, 2a, x into x square, we get x cube plus b into x to the power 4, nothing but bx power 4 plus b into 1 is nothing but b only, b into 2x square, 2bx square plus right here. That is cx cube plus cx plus dx square plus d plus ex plus f. Observe here, x power 4 plus 24x square plus 28 is equal to. Here, only 1x to the power 5 is there, so write ax power 5. Plus, again, we have only one right standard form, we get bx power 4, bx power 4 plus. X cube terms, 1, 2 is there, take x cube as common, we get 2a plus c plus x square, 5, 4, 3, 2, x square terms, x square 1, this is also 1, 2 is there, take x square as down here, x square down, we get 2b plus d plus, again x terms, take x as down here, x as down here, ax, so we get a plus cx, we get c plus ex plus e, we get plus constant terms, this is also completed, constant terms b plus completed, next d plus f, d plus d plus f is a constant. Compare with LHS and RHS. Coefficient of x to the power 5 here 0, coefficient of x to the power here 0. What is the coefficient of x power 5 here? A. So clearly A is equals to 0. A is equals to 0. X to the power 5 coefficient here not there means it has 0. So here x to the power 5 is A. So A is equals to clearly 0. X power 4 coefficient is B. Here x power coefficient is 1. So clearly B is equals 1. B is equals 1. X cube coefficient here. X cube coefficient is not there. So it takes 0. This is 2a. 2a plus c is equals to 0. Already we know that a value 0. Substitute here c is equals to 0. 2 into 0 is nothing but 0 only. We get c is equals to also 0. We get ABC values. X cube coefficient completed. X square coefficient we get 2b plus d. 2b plus d is equals to x square coefficient how much? Here 24. This is 24. Next, x coefficient. Here x coefficient is not there. So that's why that is a plus c plus e is equals to 0. A plus c plus e. A value 0, c value 0. So e value how much? E value also 0. A 0, c 0. If you substitute here a 0, c 0, we get b also 0. So, and what is the constant term? Your constant term is b plus f is equals to, we get here 28. b plus f is equals to how much? 28. Here, b value how much? B value 1. Substitute here 2 into 1 plus d is equals to 24. D is equals to 24 minus 2, we get 22. D is equals to how much? 22. So we know that A value, B value, C value, D value, E value. B value 1 plus D value 22 plus F is equals to 28. We want F value. F is equals to clearly 28 minus 23. 28 minus 23, we get 5. That is the values of A, B, C, D, E, F. If you substitute A, B, C, D, E, F value, here we get that is ax plus b. A value how much? 0 into bx means 1 by, we get x square plus 1 plus cx plus d. C value 0, d value 22. So we get 22 by x square plus 1 whole square plus ex plus f. E value 0, f value 5. So we get 5 by x square plus 1. These are the partial fractions of the given proper fraction. These are the partial fractions of the given proper fraction. That is 1, 22 and 5. These are the partial fractions of the given proper fraction. When the denominator has repeated irreducible quadratic factors means we do like this. Yes, problems. Conceptual level 1. First one already we know that. That is, which of the following is a rational factors. So all of them are, I think, total 3 options are in the form of p of x by q of x. So all are it is in the form of rational factors. And second bit also, what are given which are the improper fraction. We know that improper fraction means the degree of f of x is greater than the degree of g, or greater than or equals to the degree of g of x. Clearly observe that we get answer. Next, third one. If 2x minus 5 by x minus 3 whole square, 2x minus 5 by x minus 3 whole square equals to a by x minus 3 plus b by x minus 3 whole square. What is the value of a plus b? We want the value of a plus b. So clearly, observe here, if you do LCM, 2x minus 5 by x minus 3 whole square is equals to, here LCM means x minus 3 and x minus 3 whole square. LCM means nothing but x minus 3 whole square. So x minus 3 get cancelled, we get x minus 3 plus x minus 3 whole square, x minus 3 whole square, we get b1. Clearly, x minus 3 whole square, x minus 3 whole square get cancelled, we get 2x minus 5 is equals to a into x minus 3 plus b. A into x minus 3 plus b. So we want a and b value. If you want the b values, putting x is equals to 3 here. Putting x is equals to 3. If you substitute x is equals to 3 here, 2 into 3 minus 5 is equals to a into 3 minus 3 plus b. Clearly 3 minus 3 value is 0. 2 3 is 6. 6 minus 5 is equals to b. b is equals to 1. We get the value of a. We want the value of a. So, if you extend like this, expand like this, we get this is 2x minus 5 is equals to a into x is nothing but ax minus 3a plus b. A into x, ax minus 3a plus b. Coefficient of x here, coefficient of x here a, coefficient of x here 2. So we get a is equals to. Observe here, coefficient of x is equals to a. Here coefficient of x is equals to 2. So clearly a is equals to 2. So we get a and b values. We want a plus b. So a plus b is equals to 2 plus 1 is nothing but 2. That is the value of this. Next, fourth one, x square plus 10y, x square plus 1 whole square is equals to ky, x square plus 1 plus 9y, x square plus 1 whole square. Clearly denominator has irreducible, repeated quadratic factors. So clearly what we want is a value. So x square plus 10y, x square plus 1 whole square is equals to, here we get LCM is nothing but x square plus 1 whole square. X square plus 1, x square plus 1 get cancelled. We get k into x square plus 1 plus x square plus 1 whole square, x square plus 1 whole square get cancelled. We get 19. So denominator x square plus 1, x square plus 1 get cancelled. Compare the numerators, x square plus 10 is equals to, x square plus 10 is equals to k into x square, nothing but kx square plus k into 1, we get k plus 9. We get k plus 9. What is the coefficient of x square? Here k. What is the coefficient of x square? Here 1. So clearly k is equals to 1 is the answer. Coefficient of x square. Coefficient of x square here k. Coefficient of x square here 1. Where k is equals to 1? K is equals to 1. That is the value of k. Next, fifth one. Ax minus 1 by 1 minus x plus x square into 2 plus x. It contains one quadratic factor and one linear factors. So what is the value of a? Observe here. So ax minus 1 by 1 minus x plus x square into 2 plus x is equals to LCM is here clearly 1 minus x plus x square into 2 plus x is the LCM. 1 minus x plus x square, 1 minus x plus x square get cancelled. We get x into 2 plus x minus 1 into 2 plus x get cancelled. We get 1 minus x plus x square into this. So clearly denominator get cancelled. Total. We get here ax minus 1 is equals to x into 2 is nothing but 2x plus x into x square. Minus 1 into plus 1, we get minus 1. Minus into minus, plus x. Minus into plus, minus x square. Clearly, minus x square plus x square get cancelled. We get ax minus 1 is equal to 2x plus x. We get 3x minus 1. Compare with LHS and RHS. Coefficient of x is a. Coefficient of x is how much a? Coefficient of x is 3. So we get a is equal to 3. This is the answer. Next is one. If 2x square plus 3x plus 4y, if 2x square plus 3x plus 4y, denominator x minus 1 into x square plus 2 is equal to a by x minus 1 plus bx plus c by x square plus 2. Then the value of b. We want the value of b. If you do LCM here, we get 2x square plus 3x plus 4y, that is x minus 1 into x square plus 2 is equal to, here clearly LCM is x minus 1 into x square plus 2. X minus 1 get cancelled. We get a into x square plus 2 plus x square plus 2 x square plus 2 get cancelled. We get bx plus c into x minus 1. So clearly this denominator get cancelled. we get 2x square plus 3x plus 4 is equals to a into x square, ax square plus 2a plus bx into x is nothing but bx square, bx into minus 1 is nothing but minus bx, minus c into x is nothing but cx, c into minus 1 we get minus. Clear? This is c. That is equals to, here coefficient of x square is nothing but, take coefficient of x square a, here coefficient of x square common, we get a plus b, plus, if you take x is common, we get c minus b, plus c minus b, we get c minus b, and the constant terms here, plus 2a minus c, plus 2a minus c, here, that is 2x square plus 3x plus 4 here. What is the coefficient of x square here? A plus b. What is the coefficient of x square? Here 2. So clearly compare with LHS and RHS, we get a plus b is equals to. A plus b is equals to. A plus b is equals to. What is the coefficient of x here? 3. Coefficient of x is equals to 3. Here the coefficient of x is nothing but c minus b. So we get c minus b is equals to 1 minus 3. What is the constant term? Constant term here 4. Here constant term is 2a minus c. 2a minus c is equals to 4. We want a, b, c values. So clearly it converted into minus c minus 3 is equals to b. So b value is c minus 3. So substitute here c minus here 2a minus c value, b value, or take here c minus 3 is equals to or a plus b, anything we convert into here. C minus 3 is equals to b. C minus 3 is equals to b. A plus b value, how much? C minus 3 is equals to b. 2. So a plus c is equals to, if you transform, we get 5. This is equation number 1. This is equation number 2. Solve 1 plus 2. 1 plus 2. We get a plus c is equals to 5. 2a minus c is equals to 4. C get cancelled. 3a is equals to 9. Clearly a is equals to 3. Clearly a is equals to how much? 3. 3a is equals to 9. A is equals to 9 by 3. We get a is equals to 3. So we want b value. A plus b is equals to 2. Substitute a here. 3 plus b is equals to 2. B is equals to 2 minus 3. We get b is equals to minus 1. B is equals to how much? B value here minus 1. We want b value. So if you substitute here, a value we get c also. Or c value here, substitute here, we get c also. C is equal, c minus 3 is equal to minus 1. C minus 3 is equal to minus 1. C is equal to minus 1 plus 3. We get c is equal to 2. That is the c value. So this is b value. Minus 1. If you want c value, c minus 3 is equal to minus 1. C is equal to minus 1 plus 3. This is the value of c. This is the value of b. The third problem. X by 1 plus x square into 3 minus 2x is equals to a by 3 minus 2x plus bx plus c by 1 plus x square, the value of c. So clearly solution x by 1 plus x square into 3 minus 2x is equals to, if you rearrange here, we get 3 minus 2x into 1 plus x square as a result. So 3 minus 2x, 3 minus 2x get cancelled. A into we get 1 plus x square plus 1 plus x square, 1 plus x square get cancelled. We get bx plus c into 3 minus 2x. Denominator get cancelled. We get here x is equals to a into 1 is nothing but a plus a into x square. Ax square plus bx into 3 nothing but 3bx. Bx into minus 2 minus 2bx square. C into 3 we get plus 3c. C into minus 2 x minus 2cx. Observe here x is equal to, if you take x square as common, a minus 2 x square as common. Take x as down here and here we get x into 3b minus 2c plus constant of a and 3c. So a plus 3c. This is constant. Compare with the LHS and RHS. Coefficient of x square here, this is x. Coefficient of x square square is not there, so this is taken as 0. So a minus 2b is equals 0. A is equals to 2b. Coefficient of x is equals to here 1. So coefficient of x is equals to here 3b minus 2c is equals to 1. A is equals to 2b. A is equals to 2b. So, and constant term a plus 3c is equals to a plus 3c is equals to a constant term is not that clear. A plus 3c is equals to a is equals to b. Substitute here 2b plus 3c is equals to 0. We want the b value. So 2b is equals to minus 3c. B is equals to minus 3c by b is equals to how much? Minus 3c by. If you substitute here, we get 3 into b value minus 3c by 2 minus 2c is equals to 1. We want c value. 3 3s are minus 9c by 2 minus 2c is equals to 1. LCM here 2 is the LCM. Minus 9c 2 2s are minus 4c is equals to 1. Minus 9 minus 4 here minus 13. Minus 13 c is equals to 2. C is equals to minus 2 by 13 is the answer. Minus 2 by 13. What is the value of this one is? If you do LCM here, 2x plus 1 by x minus 1 into x square plus 1 is equals to. If you do LCM here, x minus 1 into x square plus 1 is LCM. Clearly x minus 1 get cancel. So we get a into x square plus 1 plus x square plus 1 x square plus 1 get cancel. We get dx plus c into x minus 1 numerator. So clearly the denominator get cancel. We get 2x plus 1 is equals to ax square plus 8x square plus a into 1a plus bx into x. We get bx square. Bx into minus 1 we get minus bx. C into x cx minus. So 2x plus 1 is equals to 2x plus 1 is equals to. If you take x square as a plus b and plus take x is down. This is we get c minus c minus b and constant is nothing but plus a minus c is a constant. We want a plus b value. Clearly x square coefficient here a plus b. X square coefficient here not there, so where it is 0. So a plus b is equals to 0. This is the answer. Next level for the first one. Convert it into resolve it into partial fractions, that is 5x plus 6y. 2 plus x into 1 minus x. Solution 5x plus 6y. Clearly it is 2 plus x and 1 minus x are non-irreducible linear factors. Non-irreducible linear factors. So this can be written as 2 plus x into 1 minus x is equals to ay 2 plus x plus this is b by 1 minus x. Let this value. Clearly, denominator has non-repeated linear factors. Non-repeated linear factors. So that's what taken care of. So type 1. So 5x plus 6y. This is 2 plus x into 1 minus x is equals to. LCM here this is 2 plus x into 1 minus x. 2 plus x will cancel. A into 1 minus x plus b into 1 minus x will cancel. We get 2 plus x. So denominator will cancel. We have 5x plus 6 is equals to a into 1 or take a into 1 minus x directly. A into 1 minus x plus b into 2 plus x. We want a to be values. Put a is equals to 1. A is equals to 1. Clearly this is 0. Sorry. X is equals to 1. Putting x is equals to 1. X is equals to 1. Clearly this value is 0. 5 plus 6. 11 is equals to b into 2 plus 1. 3. So b is equals to 11 by 3. 5 ones are 5. 5 plus 6 is nothing but 11. 5 plus 6 is nothing but 11. 1 minus 1. 1 minus 1 is 0. So this term is 0. 2 plus 1, 3. 3b. So b is equals to 11 by 3. This term 0. How to get this term 0 is put x is equals to minus 1. X is equals to minus 1. Minus 2 plus 2 get answer 0. We get minus 10 plus 6 is equals to a into x value minus 2. 1 plus 2, we get 3. Minus 10 plus 6, we get minus 4 is equals to 3a. We want a is equals to minus 4. So a is equals to 11 by 3 and a is equals to minus 4 by 3 and b is equals to 11 by 3. Substitute here, we get a value minus 4 by 3. So we get minus 4 by 3 into bx plus b value, we get 11 by 3. So 11 by 3 into 1 minus x is the answer. Next, second one, 1 by 1 minus 2x into 1 plus 3x is equals to a by 1 minus 2x plus b by 1 plus 3x. What is the ratio of a and b? Clearly, 1 by 1 minus 2x into 1 plus 3x is equals to, clearly answer is 1 minus 2x into 1 plus 3x only. 1 minus 2x, 1 minus 2x get cancel, a into 1 plus 3x plus b into 1 plus 3x, 1 plus 3x get cancel, b into 1 minus 2x. Denominator get cancel, 1 is equals to a into 1 plus 3x plus b into 1 minus 2x. 1 minus 2x. If you multiply, you will get 1 is equals to a plus 3ax plus b minus 2bx. b minus 2. 1 is equals to, if you take x as common, 3a minus 2b plus a plus b. Constant of is a plus b. Clearly, x coefficient here 0. X coefficient here 0. So 3a minus 2b is equals to 0. 3a minus 2b equals 0. X coefficient is not there, so x coefficient is 0. Compare with the latest number, we get it. So a plus b is equals to how much? Constant is 1. So a plus b is equals to how much? So 3a is equals to 2b. 3a is equals to 2b. We want in terms of a value. A is equals to 2b by a value how much? 2b by. Substitute here. 2b by 3 plus b is equals to 1. If you do LCM here, 3, this is 2b plus 3b is equals to 1. 2b plus 3b, we get 5b. 5b is equals to 3, b is equals to 5. b is equals to 5. We want a value. Substitute here, a is equals to 2 into b value 5 by 3 into 1 by 3. So, a value 2 5s are 10 by 9. A value how much? 10 by 9. We want ratio of a and b. So, we want a is to b. Here clearly a value 10 by 9 is to b value 5 by 3. So, 5 ones, 5 twos, 3 ones, 3 threes. So, that is equals to 2 by 3 is to, we get here 1. So that is equals to 2 is to 3. So a is to b is equals to how much? 2 is to 3. Next one, third one 1 by a square minus x square. Resolve into partial fractions. Clearly, this is solution. 1 by a square minus x square. A square minus x square can be written as a plus x into a minus x. So, a plus x into a minus x. Clearly, it is a non-repeated linear factors. So that this value is nothing but a plus x plus b by a minus x. That doesn't have this value a by a plus x plus b by a minus x. If you do LCM, 1 by a plus x into a minus x is equals to, here LCM is a plus x into a minus x. A plus x into a minus x. A plus x get cancelled. We get a into a minus x plus a minus x get cancelled. We get a plus x. A plus x. Observe here. That is denominator get cancelled. 1 is equals to a minus ax plus ba plus bx. 1 is equals to, if you take a as common here, we get a plus b. minus or plus x is common, b minus a. What is the coefficient of x here? Is nothing but 0. So b minus a is equal to 0. A into a plus b is equal to clearly 1. This is constant of clearly 1. So b is equal to a is equal to here b. If you substitute here a times of a plus a is equal to 1. 2a is equal to 1. A is equal to 1 by 2. A is equal to 1 by 2. B also 1 by 2. We get this is that is a by, that means a value 1 by 2 is 1 by 2a into a plus x plus b by b value again 1 by 2a, 1 by 2a into a minus x is the answer. 1 by 2a into a plus x plus 1 by 2a into a minus x. We want this value. So here also denominator has non-repeated linear factors. So this can be x square plus 5x plus 1 by x plus 1 into x plus 2 into x plus 3. Here we get nothing but x plus 1 into x plus 2 into x plus 3 is the answer. X plus 1 get cancelled. We get here a into x plus 2 into x plus 3 plus b times of x plus 1 into x plus 2. X plus 1 into x plus 2 get cancelled. We get x plus 3 plus total term get cancelled, total term get cancelled. Here get cancelled. X square plus 5x plus 1 is equal to clearly a into x into x is nothing but x square plus 2x plus 3x. We get 5x plus 2 equals 6. X plus 2 into x plus 3 is nothing but x square plus 5x plus 6 plus b times of x plus 3 plus c. We want b value. X square plus 5x plus 1 is equal to clearly a into x square plus 5ax plus 6a plus bx plus 3b plus c. That is, this can be written as x square plus 5x plus 1 is equal to x squared plus here 1 only, here x cubes and 5a and b is the x coefficient plus b plus constant is 6a plus 3b plus c is the constant. Compare with LHS and RHS. Clearly, coefficient of x by a, coefficient of x by 1. So a is equal to 1. 5a plus b. Coefficient of x is equal to 5. Here coefficient of x equals 5. Here coefficient of x is 5a plus b. So 5a plus b is equal to 5. Already we know the a value. 5 into 1 plus b is equal to 5. B is equal to 5 minus 5. We want b value. B value is clearly b value how much?